Class 6 count how many seeds they find under 2 trees. They show the data in a graph. How many seeds did they find in week 3 altogether? So we have the number of seeds at the side, and we can see that with each line we're counting up in tens. Now we want to know the number of seeds in week 3, but we can see that we have squares which show oak seeds and dots which show chestnut seeds. So if we go up from week 3, we can see that there were 60 oak seeds, and then if we draw a line across from chestnut seeds, we can see that that's halfway between 40 and 50, so 45. Now we want to know how many altogether, and 60 plus 45 is 105. So they found 105 seeds in week 3 altogether. Now, in how many weeks did they find more than 40 chestnut seeds? So what we can do here is draw a line across from 40, and we want chestnut seeds, which we can see are the black dots. So how many black dots do we have above 40? We have 1, 2, 3, 4, 5, so that's 5 weeks. Here are 5 letters on a scale, so we can see that we have 1 litre and 2 litres marked. Match each letter to one of the capacities in the list below. So first we have 1,200 millilitres, but as our scale is in litres, we can change this to 1.2 litres. Remember, there are 1,000 millilitres in a litre, and if we divide 1,200 by 1,000, we get 1.2. If we're given a measurement in millilitres, we can count 1, 2, 3 place values and put the decimal point here. Then we have 1.7 litres, then 1¼ litres. So that's 1.25 litres, because as a decimal, 1/4 is 0.25, because it's the same as 25 hundredths. Now 1,560 millilitres. That's 1.56 litres, because we can count 1, 2, 3 places, and if we put the decimal point here, that's 1.560, but we don't need zeros on the end of decimals, so we can just write 1.56. And then our last value is 1.07 litres. So what we can do is order these values from smallest to largest so that we can place them on the scale. So we have 1.2, 1.7, 1.25, 1.56 and 1.07. So we have our decimal points lined up, so our ones, our tenths and our hundredths digits are lined up as well. Now we can write zeros in empty squares because you can put zeros on the end of decimals without changing the value of the number. So now we can see that 1.07 is our smallest number, so that must be the point marked at A. Then our next smallest is 1.20 or 1.2, so that will be B. Then we have 1.25 or 1¼ so that's C. Then it's 1.56, so that's 1,560 millilitres marked at D, and then 1.7 will be marked at E, because that's our largest value. 2 of these diagrams are nets for a triangular prism. Put a tick in them. So we need to remember that a prism is a 2D shape that's been stretched out. So a triangular prism looks like this. We have a triangle at each end, and then we have rectangular faces joining them. So if we look at this diagram here, these 2 triangular faces will overlap, and then we won't have a triangular face at this end, so this is not the net for a triangular prism. If we look at this diagram, we can't fold to make 3 faces in the middle, so that's not a triangular prism either. Now if we look at this diagram, this edge here can fold to cover this edge, and when that happens, this edge of this rectangle can fold all the way around so that we have a triangle at this end, a triangle at this end, and then 3 rectangles in the middle. So this is one of our nets. And this is the other net because we can fold this edge round, and then again we have a triangle at each end and rectangular faces in the middle. Here are some number cards. We have 7, 5, 9, 3 and 11. Use 2 of the cards to make a fraction which is less than 1/2. So if a fraction is less than 1/2, the numerator will be less than half of the denominator. So we could use 3 as our numerator and then 11 as our denominator, because 2 times 3 is 6 and 11 is more than 6, or 3 is less than half of 11, so the fraction is less than a half. There are other possible answers for this question as well. So we could have 5/11ths because 5 is less than half of 11. We could have 3/9ths because 3 is less than half of 9, or we could have 3/7ths. But now, how much less than 1 is your fraction? So let's use 3/11ths. 3/11ths plus what is 11/11ths? Because remember, 11/11ths will be the same as 1. If a fraction has the same numerator and denominator, it will be the same as 1 whole. So 3/11ths plus 8/11ths is 1 whole, and that means it's 8/11ths less than 1. Here are 4-digit cards. We have 3, 5, 4 and 6. Use each of the digits once to make a total that is a multiple of 5. So a multiple of 5 is a number in the 5 times table, or a number that can be divided by 5 without giving a remainder. So all multiples of 5 end in a 5 or a 0. So we can work out our ones digits first, because we need to make a number that ends in 0 or 5. So if we use 6 and 4, then that will give us an answer with 0 as the ones digit, because 6 plus 4 is 10. And then, because we're using each of the digits once, we can have our other digits as the tens digits, and 36 plus 54 is 90. That's a multiple of 5, because when we divide 90 by 5, we don't get a remainder. And with addition, we can switch the digits around without changing the total, so there are other possible answers for this question. Round each of these numbers to the nearest whole number. First, we have 13.7. To round a decimal to the nearest whole number, we can circle our ones digit, so that's the digit before the decimal point, and then we look at the digit after the decimal point. Remember, when we're rounding, if it's 5 or more, we round up, and here we have a 7. So that means this 3 is going to become a 4. So 13.7 is nearest to 14. Now we have 8 and 3/8. So 8 and 3/8 will be between the whole numbers 8 and 9, but it will be closest or nearest to 8, and that's because 3/8 is less than 1/2. So 8 and a half would be right in the middle of 8 and 9, but 8 and 3/8 would be closer to 8, because 1/2 is the same as 4/8, and we have less than that. Now we have 3.38. Again, when we're rounding to the nearest whole number, we find our ones digit, so the digit before the decimal point, and look at the digit after the decimal point. This time it's a 3, and if it's 4 or less, we round down. So the 3 stays the same, which means that 3.38 is nearest to 3. Write in the missing numbers in this sequence. So we have 480, then 240, and we need to spot that 240 is half of 480. 480 divided by 2 is 240. So this sequence is a division sequence. Lots of the sequences that we've looked at so far have been either addition or subtraction, but you can have sequences with multiplication or division as well. So then, to get our next number, if the sequence rule is divide by 2, we can divide 240 by 2, and that will give us 120. Then 120 divided by 2 is 60, and that's our next number. 60 divided by 2 is 30, so that's this box here. And then 30 divided by 2 is 15. So the rule for this sequence is divide by 2. Find two square numbers that total 45. So we need to remember that square numbers are what we get when we multiply a number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and so on. But we need numbers that total 45. So we can have 36 and 9, and that gives an answer of 45. And both 36 and 9 are square numbers because they're numbers we get from multiplying a number by itself. The temperature in the fridge is 4 degrees. The temperature in the freezer is minus 18 degrees. What is the difference in temperature between the fridge and the freezer? So if we draw a number line, we know that the temperature in the freezer is minus 18. And from minus 18, we need to add 18 to get to 0. But then we need to get to 4. So if we add 4, that takes us to 4. So to get from minus 18 to 4, we need to add 18 and then another 4. So that's adding 22 altogether, which means that the difference is 22 degrees. Jamie takes 3 parcels to be posted. One parcel has a mass of 750 grams. Another weighs 2.8 kilograms. The total mass of the 3 parcels is 5.13 kilograms. What is the mass of the third parcel? So here we have a mass in grams, but elsewhere in the question we have kilograms. So we need to get our units the same. We need to change 750 grams into kilograms. Remember, there are 1,000 grams in 1 kilogram. So that means we can write 0.750 kilograms because to divide 750 by 1,000, we can imagine the decimal point on the end and then move it 1, 2, 3 places to the left. And then because the decimal point is now in front of the 7, we just need to write 0 as our ones digit. But we don't need to write zeros on the end of decimals, so we could just write 0.75 kilograms. So we know that one parcel is 0.75 and another is 2.8. So if we work out 2.8 plus 0.75, that will give us the mass of these 2 parcels together, and then we can subtract that total to find the mass of the third parcel. Remember, when we're adding decimals, we line up the decimal points, write zeros in empty squares, copy down the decimal point, and then we can add using column addition, so we get 3.55. So that's the mass of 2 parcels, but the 3 parcels have a mass of 5.13. So if we subtract 3.55 from that, we'll get the mass of the 3rd parcel. Again, we can use column subtraction and we get 1.58. So the mass is 1.58 kilograms. And we can check if we add 0.75, 2.8 and 1.58, we should get a total mass of 5.13.